Okay, to continue our notes, we are on example 4, Amelia. We are on example 4. But you're facing. Huh? So we have let f of x equal absolute value x minus 3 and then minus 5. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So let's review. If we're doing horizontal, where is it located? Inside. And then what also do I need to know about it? It's opposite operation, opposite. And I'm writing opposite operation because the word opposite in math means negative positive, but this is not negative positive. This is, instead of multiplying by 1/3, we're actually going to flip it and multiply by its reciprocal. So the reciprocal of 1/3 is 3. That's what we're going to be using. This is the kind where we are going to say f of, and it goes inside 3x. Last class, we talked about what does that mean? What does it mean? We replace, what does it mean? We replace x with parenthesis 3x. That's what it means. So in our equation, we have absolute value, parenthesis 3x, close parenthesis minus 3, close absolute value minus 5. Does that simplify at all? Kind of. So g of x equals absolute value 3x minus 3 minus 5.
Why do we replace x with 3x again?
Why do we replace it with 3x? Because it's horizontal. So the horizontal kind are the ones that replace. And because the factor is 1/3, we have to flip it and use the number 3 instead. So the second part, write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So this one's a vertical stretch. Vertical goes where? Outside. And the factor is 2. Since it's vertical, we don't need to change it. We're just going to do 2 f of x. And do 2 times f of x. So 2 times, what is my f of x? Absolute value, x minus 3, close absolute value minus 5. I'm doing 2 of that, twice that. That does simplify to g of x equals, it doesn't matter. 2 absolute value x minus 3, close absolute value minus 10. Where did I get the 10? Right, we're going to distribute the 2 to the absolute value and to the 5, minus 5. Why didn't I change my 3 to a 6? Because it's outside. It's not inside, so we don't go in the inside. We stay on the outside. No, I think I put my arm on the cord. There we go. No, it's still recording. It says check your answers with your graphing calculator. Let's pause and do one of these graphing calculator checks. Then you won't be able to use it on a quiz. Wednesday. Okay, so what I'm doing first, just making sure I have the same equation, okay, is I'm going to my y equals button, which currently is red. You can see it. I touched it. It's red. And then I'm typing in absolute value x minus 3 minus 5. If you do not have your graphing calculator today on your computer, you could use Desmos. Desmos is going to help you do the same thing, but you can't use Desmos on a quiz. Amelia? How to find absolute value?
Yeah.
Okay, it's under math. And then we go over to the NUM, N-U-M. So these things, like Amelia just said, I forget where to find absolute value. That's why you have to have your graphing calculator in class. Because on a quiz, how are you going to find it? Start pressing every button, right? Okay. The equation's the same one from the notes. Absolute value x minus 3. Close the absolute value minus 5. So if you're doing this on Desmos, you can type in absolute value in Desmos too. Then we are going to type the one that we just got, which was 2 absolute value, x minus 3. And then we got minus 10. So you go ahead and hit graph. If yours did not graph it correctly, or if your window's all messed up, you can hit Zoom 6 to fix it. If you have an error, tell me right away so I can help you fix it rather than 10 minutes later. Tell me right away. Who doesn't have their calculator today? So I know like who still needs to bring it. You or him?
Both of them.
Oh, you're telling on them. Got it. Got it. All right. Okay.
2 times the absolute value of x minus 3.
What?
I'm using Sterling Caesar.
Oh, I don't care. I'm just going to go back to y equals real fast. And the mistake that some people will make on this one will be, and you guys don't have to type the mistake in. I'm just going to show you. The mistake that some people will do is they'll just put the 2 in front, but not change the 5. So we can kind of see the difference between those graphs. So the third one is not correct. So when we talk about stretching it vertically, you have to imagine this blue graph stretching up and down, where the black graph, it didn't stretch up and down. Its arms just kind of moved in closer together. But the red one looks like it's stretched up and down, if that makes sense. So you can use your graphing calculator to see if it makes sense. Okay, student practice. Write a function g whose graph represents the indicated transformation of the graph of f. Use a graphing calculator to check your answer. I'm going to stop talking for a minute, and I want you to try one or both of these, depending on how far you can get in a minute. Think, is it vertical or is it horizontal? Does it go inside? Does it go outside? If it's horizontal, it's opposite operation. Does it go inside or outside? Mario, first one. Inside. Darren, what's the stretch for the first one? That should be in the next. Should it be a 2? Should it be a 2? Question 5 says horizontal stretch by factor of 2. Horizontal says inside. I've already asked a couple of you that. So if it's inside, we also have to do the opposite operation. Opposite. Am I going to use the number 2? No. I'm going to use the reciprocal 1 over 2. So we're going to do f of 1/2 x. Now, that means replace x with parenthesis 1/2 x. So I start with a 4. I replace x with 1/2 x. Then I do a plus 2. Can I simplify that? Yes. Should be able to. 2x plus 2. Let's look at what a horizontal stretch is going to look like on our graphing calculator. So we're going to graph 4x plus 2 and then 2x plus 2. And you know what? Then I'm going to graph 8x plus 2. How would somebody get 8x plus 2, which is wrong? Because they didn't reciprocate it. Okay, so I'm going to show you how looking at the graphing calculator might help you figure out I did something wrong. So the first 2 are the original and then the correct answer. The black one, the third one, is going to be the incorrect answer. So the first one is the original, the red one is the correct answer, and then the black one is the incorrect. So if we think about a horizontal stretch, that means it needs to become more horizontal. So if you look at the blue one, I think I can make my blue, I think I can make my graph bigger. Hold on, forget. There, made my graph bigger. Okay, we look at the blue one, that's the original, and then we look at the red one's more horizontal. Horizontal stretch makes it more horizontal. And then the black one is less horizontal. So we can see the black one can't be right. So that might help you if you accidentally forget to flip it and then you graph it and say, does this graph make sense? All right, number 6, we are doing a vertical shrink by a factor of 1/3. So vertical goes on the outside. So we'll have 1/3 outside of f of x. So I'll have 1/3 outside of absolute value x minus 3. I'm going to simplify that. Oh, I was about to call in somebody. Jason, can you tell me what I would get when I simplify this? I'm sorry, I couldn't hear you, hon. Oh, simplify this step here. What will I have for my g of x?
1/3 x. And then absolute value.
Correct, minus 1, because this previous step, we have to distribute that 1/3 to both parts. Okay, so let's graph that one and see what it looks like. It says it's a vertical shrink. So is this one going to be more vertical or less vertical? A vertical shrink will mean it's going to be less vertical. Let's see. To get a fraction, well, I don't need the fraction yet. I'll tell you in a second. Let me get my first. What was it? Absolute value, I forgot. X minus 3. Okay. So to get a fraction, if you have the newer calculators, alpha y equals enter will give you the little fraction. Otherwise, you just have to put your fraction in a extra set of parentheses.
Wait, can you do that again?
What do I need to do again, hun?
Subtraction.
Oh, alpha y equals, enter. I'm also going to type in what I think might be somebody's mistake. So I think a mistake could be 1/3 and then absolute value x. What do you guys think the mistake would be? -3. That would be the mistake one. So the same order of colors. I didn't pick the colors. That's the order they go in. Okay, so this is the thing that I think is like the most maybe confusing.
Wait, can you get the fraction again?
Alpha and then y equals, enter. Did it work?
Yes.
Okay. So I think this right here might be one of the most confusing things about looking at your vertical stretch and understanding if you're correct or not, or a vertical shrink. For this V shape, we are shrinking it vertical, but because it's not starting at 0, 0, it's not starting right in the middle. Ooh, I have a really good way of showing you this actually. Because it's not starting in the middle, we have to think about both the top and the bottom kind of shrinking, getting more horizontal, which is why the red is the correct answer. Because it's not starting right in the middle at 0, 0. The black one here, that one, the arm's just open, but it's not changing its entire graph vertically. It's only changing how wide it is. It's not actually like, gosh, I wish I could like, I'll show you with Desmos. It's so much easier to show you in Desmos. Let me show you. So it was absolute value x -3, right? Yeah. Okay, so then to this, I'm going to put 1 over a number out here. I'm going to make that a slider. And let me put my original in there again, just so we can compare it. I think this is the best way to actually see what's happening. Okay, so I'm going to use my slider. And as I change this value, you're going to see how the graph will shrink vertically, how it's going to shrink vertically. You see how it's getting closer and closer to being horizontal? That it's actually, I went too far. It's actually moving the vertex point, that point in the middle with it, because the whole graph is trying to get closer and closer to horizontal. You guys see that? That's why that number on the outside also changes. That -3 changes into a 1 when we do the 1/3. If I were to do a stretch, which is not what this question was doing, but if I were to do a stretch, you would see that vertex point getting further and further away because it's getting more and more and more vertical. It's getting close to vertical. If it goes vertical, the whole thing disappears. It's getting close and close to vertical. Okay. Oops. All right, almost done. Combining transformations. When we combine transformations, you're going to see the words followed by. That means you have to follow the order. You have to follow the order. The first part is a vertical shrink by a factor of 0.25. Vertical shrink, is that inside or outside? Outside. And the graph is just f of x equals x. So the first thing we're going to have is on the outside, 0.25 on the outside of f of x. So I do 0.25 on the outside of the function, which is just x. And I'm going to simplify that. And I'm going to call it h of x. My final answer is not h of x. My final answer is g of x. This h is like halfway through. We did the first half. I can call it whatever I want, but that's why I'm calling it h, because it's halfway. So after we do that, then we have to do a second part. And the second part comes after the word followed by a translation 3 units up. So I'm going to take my h of x, which is my halfway equation, and I'm going to transform that 3 units up. So that goes on the outside. So the h of x is the h function, 0.25x. Then I have to add 3 to that. Can I simplify anything here? No. So this is just my answer. G of x equals 0.25x plus 3. So when you have multiple transformations, you have to do them in order. This next one says, let the graph of G be a translation 6 units down, followed by a reflection in the x-axis. Translation 6 units down, followed by a reflection in the x-axis. So the first thing we have to do is the 6 units down. So f of x, we're going to take away 6. Vertical goes on the outside. Our f of x is absolute value of x for this one. So I take my absolute value of x, subtract 6. That's my h equation. That's my halfway equation. There's nothing really to simplify. But if so, I would do it here. So now we're going to do the g equation, which is the final one that says, now we're going to do a reflection in the x-axis. How do we do a reflection in the x-axis? In front of what? Okay, so first of all, my directions in function notation, my directions say negative in front of the function. Oops, it's not an F anymore, it's an H. Negative in front of the function. That's my directions. So what I heard you say was put a negative in front of the absolute value. Is this the correct answer? I haven't said if it is or not.
You have to distribute it, so you have to multiply it by 6 too. So it'd be positive 6.
Or is that the correct answer?
No, because it's on the outside.
What's this say? Let's check our answer, okay? Let's go to our graphing calculator. Let's type in the original. Actually, are we confident that this part is correct? Okay. I feel like we should be confident this part is correct. Let's type that one in as our original, and we'll type both of these in as the second and third and see which one makes the most sense. And if you don't have your graphing calculator, you saw me using Desmos. Use Desmos. What? I'm going to use the absolute value x minus 6 as like my original because I feel pretty confident that that part's correct. Because all we had to do was move that one down 6. So that one I feel pretty good about. So then we're going to try, make sure you hit the negative symbol, not the subtraction symbol, because you will have an error. I'm going to try absolute value of x, and then I'm going to do minus 6. And then I'm also going to try negative absolute value, 8IC, x plus 6. I'm going to try both of these and see which one makes more sense. What, Ida? The negative symbol is right down here at the very bottom,
Oh,
right next to the, woo, there's a lot going on here. It's pretty. It's made a pretty design. Okay. So the order is the blue was the original, the red was the second one, and the black was the third one. We're trying to reflect this in the x-axis. So if you guys are looking for our x-axis, I have my little cursor like going back and forth on it, so it's making like a little symbol. You can see where I am. Okay, that's my x-axis. Which color is reflecting in the x-axis? The black one. Okay, the red one reflected over like y equals -6. But the black one is the actual reflection in the x-axis. So my black one, if we go back to my equations, that was the one where you had to distribute the negative sign. So Dimitri, who yelled that out, was correct. So this is the correct answer here. Remember, if you have negative of the entire function, it has to go to the entire function, not just in front. It goes to the entire function. And look at how we're checking our answers using our technology. Okay, I'm sorry. All of my students that have gone to college and come back to talk about, because I teach a lot of pre-calculus kids, so they'll go to college and take calculus. They all come back and their calculus classes all on the computer. Like you have to answer all your questions on the computer. So let's get used to it now because it's not going away. I'll tell you that. Technology is here to stay. I want to make up one more just because we didn't have as many examples on day 2 here as we did for day 1. I'm going to make up one more where I see people make a lot of mistakes. So I'm going to make up one more. I'm totally making it up from scratch here. Give me a second. We'll say f of x is, let's do x squared. We didn't do any x squareds yet. Let's do x squared. We're going to have a horizontal shrink by a factor of 1/3, followed by a translation 4 units left. Okay. So we're doing a horizontal shrink by a factor of 1/3, followed by a translation 4 units left. We're going to start at f of x equals x squared. So what do we have to do first? What do we have to do first?
what we're replacing x with.
Well, both of them are horizontal transformations, but the one we have to do first is the one that comes first in the sentence before the words followed by. We have to do the shrink by a factor of 1/3 first. Because it's horizontal, it's the replacing kind. It's the inside. And because it's horizontal, we have to use the reciprocal because we do opposite operation. So we're going to have f of what? 3x. That means replace x with parenthesis 3x. So in my equation, I'm going to replace x with 3x and then square that. Okay. We can either simplify now or move forward. It doesn't really matter for this question so much. Are we okay with simplifying real fast? You guys okay? Because normally I say if it says followed by, then simplify. So I'm going to have my h of x as, what is 3x squared equal to? 9x squared. 9x squared. Okay.
Yeah, didn't we remove the square?
We squared the 3 and squared the x. So x squared is x squared. So the square didn't go away. It just distributed in to both things. All right, now we're going to follow by a translation. 4 units left. Anything horizontal is going to be the replace kind. And then left is actually going to mean we're going to use a plus sign. Opposite operation. So this is going to be h of x plus 4. So wherever I see an x, I'm going to replace it with x plus 4. So 9 parenthesis x plus 4 close parenthesis squared. So anytime we do a horizontal, we are replacing the x. So we don't just put a plus 4 at the end. We replace the x with x plus 4. This exact same question, sorry, hang out with me for 2 more moments. This exact same question, what if we didn't simplify it? What if we didn't simplify it? What if we used, so I'm still going to get a correct answer. If I didn't simplify it, what if I used this as my h of x? And I do the same exact step, h of x plus 4. I'm just using a different h of x. I would still replace x with x plus 4. But for this one, I could actually simplify at the end. And I would have my g of x. I forgot to write g of x for the first one. I would have my g of x as parenthesis 3x plus 12 squared. These 2 equations are completely exactly equivalent. They look really different, but they are equivalent. It just depended when I simplified. Okay, so your assignment today is to finish up that worksheet if you started it. If you didn't start it, to start the worksheet. Today's assignment, you will be checking your answers off my answer key and submitting. Just yours. So make sure you do corrections. Make sure you know where you made your mistakes. Tomorrow's assignment will be a review over this stuff, which will have like a Canvas quiz where you can actually hit check and see if you're doing it right. So that's going to really tell you if you're going to be ready for that quiz or not. So today, so you can look at my answer key. Tomorrow, you'll have to, fingers crossed, get them right and check them with Canvas, okay? All right, go ahead and get started.